Hello students! In our previous video, we learned that sequence is a set of numbers which are arranged according to any specific pattern. Or we can say that sequence is a set of numbers which follows a definite logical rule. It need not always be some mathematical formula, but it should be logical. For example, the set of multiples of 2 is a sequence because they are arranged according to a definite rule, which is 2n. The following set of odd numbers is also a sequence, or this set of prime numbers also follow a specific logical rule, that is, they are arranged increasing order of the prime numbers. But now observe this sequence: 2, 4, 6, 8, 10, 12. Yes, these are the multiples of 2. Or here we can say that next number is obtained by adding 2 to the previous number. As you know, each number here is one term. So if I ask you what will be the term after 12, can you answer this? Yes, it is simple. It will be 14. And how did we do that? Observe that here 2 is the first term. So n is equal to 1. So if we keep this in the formula 2n, we get 2 into 1, that is 2. Similarly, if we take 4, which is the second term, and so n will be 2 here. Therefore, 2n, which is equal to 2 into 2, is equal to 4. And then the third term will be 2n, which is equal to 2 into 3, which gives us 6, and so on. We have used this formula 2n here because all the numbers are multiples of 2. Thus, to get the term after 12, we count its n. Here 12 is the sixth term. So the term after it will be seventh term. That is, we have to find for n equal to 7. Therefore, putting 7 in our formula gives us 14. Thus, term after 12 will be 14. And what about this sequence? 3, 5, 7, 9, 11, 13, 15, 17 and so on. Can you identify rule here? Yes, it is 2n plus 1. And why so? Because all these are the odd numbers. So if I ask you what will be the term after 17 here, the method remains same for this as well. First count the number of term we want to find, that is find n. Say here we want term after 17, which is the 8th term of the sequence. And so we want to find the 9th term. Thus substitute n in the formula and we get 19. Thus the term after 17 will be 19. Now students, observe both these sequences together. What did you find common for both these sequences? Pause the video, take a second and think about it. You'll observe that both these sequences have some formula to find the next term. In fact, with the help of this formula, we can calculate any nth term of the sequence. Such a sequence which is based on particular formula is called progression in maths. I repeat, such a sequence which is based on particular formula is called progression in maths. Thus, progression is yet another type of number sets which is arranged according to some definite rule. In short, progression is also a sequence but with formula. Now observe this yet another sequence. It is of prime numbers 2, 3, 5, 7, 11, 13, 17 and so on. So the rule is prime numbers. Now can you tell me whether this is a progression or not? The answer is clearly no. Now you may be wondering that a set of prime numbers should be a progression because we can predict its nth term. But hold on and think once. We said that a progression needs a specifically stated formula. And it is to be noted that prime numbers cannot be predicted with the help of any formula. Till date, the formula for nth prime number is not to be found. This means that we can only calculate or predict the nth prime number with the method of writing each successive number in the form of list and not any formula. So we can say that list of prime numbers is indeed a sequence but not a progression, since it is based on some logical rule but does not have any formula to calculate its nth term. Let me repeat it again for you. The difference between a progression and a sequence is that a progression has a specific formula to calculate its nth term, like list of odd numbers where we used 2n plus 1 formula, whereas a sequence can be based on a logical rule, like a group of prime numbers, which does not have a formula associated with it. Therefore, 3, 5, 7, 9, 11, 13, 15, 17 and so on represents a progression, where nth term is given by 2n plus 1. And on the other hand, 2, 3, 5, 7, 11, 13 and 17 represents a sequence and not a progression. Because although it is based on a definite logical rule, that is prime numbers, there is no formula to calculate its nth term. Now students, since we have understood the difference between sequence and progression, there are different types of progressions in mathematics. They are arithmetic progression, geometric progression, and harmonic progression. Arithmetic progression is a sequence of numbers in which each successive term is the sum of its preceding term and a fixed number. This fixed number is called a common difference. It is also represented as AP in short. The example of AP is 2, 4, 6, 8, 10 and so on. Here, the next term is obtained by adding 2 to the previous term, and so 2 is the common difference here. Now, a geometric progression is a sequence where every term bears a constant ratio to its preceding term. Consider the following example of geometric sequence: 1, 4, 16, 64 and so on. Observe that here, if we take ratio of 4 to its preceding term, that is 1, we get 4. Similarly, if we take ratio of 16 with its preceding term 4, we will again get 4. Same, ratio of 64 to 16 will give us 4. Thus, here 4 is the common ratio. Note that it is not the common difference, it is the common ratio. A harmonic progression is a sequence obtained by taking the reciprocal of the terms of an arithmetic progression. Say for example, the sequence 2, 4, 6, 8 of natural number is an AP. Here, we get the next term by adding 2 to it. Now if we take reciprocals of each term, we get 1 upon 2, 1 upon 4, 1 upon 6 and 1 upon 8 and so on. And this is a harmonic progression. Students, we can also look at this like this. Sequence will be harmonic progression if the reciprocal of all the terms of that progression forms an arithmetic progression. Say in our example, if we consider this sequence first, 1 upon 2, 1 upon 4, 1 upon 6 and 1 upon 8 and so on. Now take its reciprocal, that is 2, 4, 6 and 8, and check whether they form an AP or not. If yes, then this sequence will be harmonic progression. Now since this is confusing, let's quickly have a bird's eye view of this concept again. In an arithmetic progression, each successive term is obtained by adding the common difference to its preceding term. For example, 2, 4, 6, 8, 10. In a geometric progression, each successive term is obtained by multiplying the common ratio to its preceding term, and the reciprocal of the terms of an arithmetic progression is harmonic progression. But out of all these, you just have to worry about arithmetic progression. for your exam point of view. Other two you don't have to worry about. They are just for your information and understanding. So what is an APE and what are the terms used in it, we will see in our next video.